Today I wanted to talk about the relationship between electric field, force, voltage, and electric potential. So, starting with electric field, we can see using this diagram of two simple point charges in a field, separated only in the x direction by a distance of r, that if we start with the equation, our electric field is going to be kq1 over r squared times the separation vector, and the separation vector is going to be in the x direction r from from our source to the observation. It's going to be r, and then the magnitude would be r, and the unit vector is the separation vector divided by the magnitude, so that's just 1 in the x direction, and then 0 in the y, 0 in the z. So then, in order to get voltage, we can integrate over the distance, and we see by that in the x direction multiplied by the unit vector, we have 1 dr. In the y and the z, it's multiplied by 0, so those both end up being 0 in the end. If we continue to integrate over r, you can see that the equation turns out to be exactly what you would expect to be for voltage. And when you use the magnitude of the x, y, and the z, you get the exact equation. And then if we were to move over to force, all you have to do is multiply by q, and then in order to get the electric potential, you can integrate in a similar way over the distance of r using the unit vector to get electric potential to be kq1 q2 over r.